A silent stone circle waits for a sunrise that only comes once a year. This is the profound mystery of our prehistoric past. For generations, the story we learned was simple. Early human societies were small groups of hunter-gatherers, focused purely on survival. Their understanding of the world limited to the immediate and the tangible. Yet scattered across the globe, from the wind-swept plains of Britain to the mountains of Peru, they left behind monuments of staggering ambition and impossible precision. These colossal stone structures, built thousands of years before the pyramids, align with the sun, the moon, and the stars with an accuracy that challenges our modern assumptions. How did people without written language, metal tools, or even the wheel achieve such sophisticated feats of engineering and astronomy? By the end of this exploration, you will see the dawn of human science in a radically new light, pushing its origins thousands of years further back into the mist of prehistory. We are forced to ask what these silent stones are trying to tell us about the intellect of our ancestors. What does true ingenuity look like when you strip away all the technology we take for granted? These monuments are known as megaliths, a word meaning simply great stone. It is a fittingly broad term for a phenomenon that spanned continents and millennia. From roughly 6,500 to 3,000 years ago, long before the rise of classical civilizations, cultures across Europe and beyond were moved to build with colossal, often unshaped stones. This was not a single, unified project but a recurring idea, a profound cultural impulse that surfaced independently in different places and times. The forms they took are hauntingly familiar. There are the solitary sentinels, single standing stones known as menhirs, often planted in lines that stretch for miles across the landscape, as at Carnac in France. There are the circles like Stonehenge, where lintels connect uprights in a geometry of stone. And there are the chambered tombs like Newgrange in Ireland, great mounds of earth with narrow, precisely oriented passages leading to inner chambers. What binds these diverse structures together is more than their material. It is their scale, their permanence, and the undeniable intention behind their placement. They represent a colossal investment of labor and community effort, a decision to reshape the very land in a way that would endure for ages. This widespread practice tells us something crucial. The drive to build monuments aligned with the heavens was not a fluke or an isolated experiment. It was a fundamental thread in the fabric of many early societies, a silent language written in stone and sky, waiting for us to learn how to read it. This silent language of stone and sky demanded a new way of listening. To move beyond simple awe into genuine understanding, a unique field of study emerged, one that bridges the gap between ancient earth and ancient sky. This is archaeoastronomy. It is not simply the study of old astronomy, but a rigorous fusion of multiple disciplines, a detective story where the clues are buried in the ground and written in the stars. Archaeologists provide the context, excavating sites to understand the culture that built them. Astronomers bring the precise celestial mechanics, calculating the positions of the sun, moon, and stars millennia ago. Anthropologists offer insight into how traditional societies perceive and mythologize the cosmos, and statisticians provide the critical rigor, helping to answer the most difficult question of all. When we see a stone aligned with a sunrise, is it a purposeful design or merely a coincidence? The goal is to separate random patterns from intentional signatures, to distinguish between a structure that happens to face east and one that was meticulously engineered to capture the first sliver of sunlight on the winter solstice. This interdisciplinary approach transforms our gaze. We are no longer just looking at a pile of old rocks. We are learning to see through the eyes of the builders, to perceive the landscape as they did, not as a passive backdrop, but as a living calendar and a sacred map. It is through this scientific lens that the true sophistication of these monuments begins to come into sharp, undeniable focus. The most compelling test of this scientific approach lies at a place whose silhouette is known around the world. Stonehenge stands as the archetypal megalith, a symbol so powerful it can eclipse the true complexity of its design. To understand it is to peel back layers of time, for this was not a single act of creation but a multi-generational project spanning over 1,500 years. Its story begins around 5,000 years ago with a simple circular ditch and bank, a sacred enclosure known as a henge. Within this space, the earliest builders placed the Aubrey holes, a ring of 56 pits whose purpose remains one of Stonehenge's deepest mysteries. Centuries later, the iconic phase began. Enormous sarsen stones, each weighing up to 50 tons, were dragged from quarries over 20 miles away. These were shaped and assembled into the towering trilithons, the giant three-stone gateways, and the outer circle capped with lintels, creating the monument we recognize today. The precision of this engineering is staggering, but the true genius is written in its orientation. A long processional avenue approaches the circle from the northeast. At its end, just outside the monument, stands the solitary heel stone. If you stand at the center of the circle and look down the avenue on the morning of the summer solstice, you will witness the sun rising directly over the tip of the heel stone, its light flooding into the heart of the sanctuary. Conversely, at the winter solstice sunset, the sun aligns perfectly between the uprights of the great central trilithon, marking the year's darkest day. These are not vague approximations. They are precise, repeatable astronomical events locked into the architecture, yet the sun was only part of the story. Researchers studying the 4 outlier station stones and the enigmatic Aubrey holes have proposed an even more sophisticated function. Their positions appear to align with the extreme rising and setting points of the moon over its complex 18.6-year cycle. A cycle far less obvious than the annual solar journey. This suggests Stonehenge was more than a solar calendar. It was potentially a grand cosmic calculator, a stone-built machine designed to track the intricate dance of both the sun and the moon, a project so vast it required the sustained vision of countless generations. Yet the ambition of Stonehenge is matched by a monument of equal mystery across the sea. In the rolling green hills of Ireland's Boyne Valley, a great grassy mound rises from the earth. This is Newgrange, a passage tomb built over 5,000 years ago, making it centuries older than the pyramids of Giza. From the outside, it appears as a man-made hill, its facade studded with white quartz stones that glitter in the sun. But its true wonder is hidden within, a feat of engineering so precise it feels like a magic trick written in stone and light. A single, narrow passage, 19 meters long, leads deep into the heart of the mound. At its end lies a cruciform chamber, a sacred space where the remains of individuals were placed in a final resting place. This chamber is in perpetual darkness, sealed away from the world for most of the year. But above the entrance to the passage, the builders engineered something extraordinary. They constructed a small, rectangular opening now called the roof box. It is not a random hole, but a carefully crafted aperture, a window of stone positioned with breathtaking accuracy. For just a few days around the winter solstice, something miraculous happens. As the sun crests the horizon on the shortest day of the year, a narrow beam of golden light enters this roof box. It travels down the entire length of the dark passage, a journey that takes about 4 minutes, until it finally floods the inner chamber with a radiant glow for approximately 17 minutes before retreating. The effect is not a vague wash of light. It is a focused, dramatic shaft, illuminating the intricate spiral carvings on the chamber walls, symbols whose meaning is lost to time. To achieve this, the builders had to understand the precise azimuth, the exact point on the horizon where the sun rises on the solstice. they had to calculate the correct height and angle for the roof box aperture. They had to engineer the passage slope and alignment so that the beam would travel straight to its target. This was not a happy accident. It was the result of generations of meticulous observation, of watching the sun's path shift minutely year after year until its southernmost point was memorized in the landscape. This was a culture that could predict a celestial event and then literally build a mountain to capture its light, transforming a moment of astronomical change into a tangible, awe-inspiring experience deep within the earth. But what happens when a single monument is not enough to contain the knowledge of the sky? In the windswept region of Brittany, on the northwest coast of France, an entire landscape becomes the instrument. Here, near the village of Carnac, you do not find a solitary circle or a single mound. You encounter something that feels less like architecture and more like a vast, silent army turned to stone. Over 3,000 individual standing stones, known as menhirs, are arranged in astonishingly straight, parallel rows that stretch for kilometers across the countryside. There are multiple alignments, with the most famous, the Menek alignments, consisting of nearly 1,100 stones in 11 converging rows. Walking among them is a disorienting experience. The stones are not uniform, they vary in height, some shoulder high, others towering overhead, creating a rhythmic, undulating pattern that seems to pull your gaze toward the horizon. The sheer scale of labor is almost incomprehensible. To quarry, transport, and erect this many stones represents a communal effort of staggering proportions, spanning generations. This was not a temple you entered, it was a ritual landscape you moved through, a domain where the human and celestial realms met on a grand scale. For decades, the purpose of these rows seemed utterly mysterious, a labyrinth without a center. Then researchers began to look not just at the stones but through them. They proposed a hypothesis as bold as the site itself. What if these long, straight rows were not meant to be walked down but looked along? Imagine standing at one end of a row at dawn on a significant day. The stones would form a precise visual corridor, a giant sightline that would frame the rising sun or moon as it crested a distant hill or notch in the landscape. Different rows could be aligned to different celestial events, the summer solstice sunrise, the winter solstice sunset, or the extreme rising points of the moon during its long cycle. In this view, the Carnac alignments become a colossal observatory, a permanent calendar etched directly into the earth. The entire landscape transforms into a map of the sky, where the positions of heavenly bodies were not just observed, but physically anchored by these endless lines of stone. It suggests a society so deeply attuned to celestial rhythms that they felt compelled to replicate that order on the ground, to make the invisible cycles of time visible, tangible, and immense. Far to the north, where the sea meets the sky in a constant, brooding dance, another community was writing its knowledge into the land. The Orkney Islands, a windswept archipelago off the coast of Scotland, hold one of the most complete and profound Neolithic landscapes in the world. Here, the monuments do not stand in isolation. They speak to each other across the hills and lochs, forming what many researchers now see as a vast, integrated complex, a true Neolithic cathedral under the open sky. At the heart of this complex lies Maeshowe, a great grass-covered mound that from the outside appears as a gentle, unassuming hill. But like Newgrange, its secret is one of precise alignment and dramatic light. Its long, low entrance passage is engineered with an almost obsessive accuracy. For most of the year, this passage leads only into a profound and silent darkness, a central chamber built from colossal, finely fitted stone slabs. Yet for a few precious days around the winter solstice, the setting sun in the southwest performs a miracle. Its fading light rolls down the hills across the loch, enters the narrow passage perfectly, and travels its entire length to strike the rear wall of the inner chamber, illuminating carvings left by later Norse visitors. This alignment is so exact that modern visitors are taken there to witness it, a tradition that likely stretches back over 5,000 years. The builders did not just mark the solstice, they captured the last light of the year's shortest day, bringing it into a space of deep ritual and memory. But Maeshowe was not alone in its purpose. A short walk away, standing sentinel on a narrow isthmus of land between two lochs, are the stones of Stenness and the ring of Brodgar. These are great circles of towering, slender monoliths, some over 5 meters tall. They are not enclosed like Stonehenge, but open to the vast Orkney sky, their stones framing dramatic vistas of water, land, and horizon. Archaeoastronomical studies suggest these circles, along with other surrounding mounds and standing stones, are not randomly placed. They appear to form a network of intervisible sightlines. A person standing at the center of the ring of Brodgar might see the winter solstice sun set behind a specific distant notch in the hills, a notch that also aligns with Maeshowe's entrance. The stones of Stenness may have framed the rising moon at a key point in its cycle. This transforms the entire landscape from a collection of separate sites into a single, functioning instrument. It suggests a shared cosmological vision so powerful that an entire community coordinated their efforts over centuries to build it. They were not just constructing individual monuments, they were sculpting their entire world into a map of their beliefs, connecting the realm of the ancestors within tombs like Maeshowe to the cycles of the sun and moon marked by the great circles. This was a unified statement written in earth and stone, declaring that humanity, the heavens, and the land were all part of one inseparable whole. While the grand landscapes of Orkney were being mapped to the sky, a different kind of precision was being achieved on a sun-baked archipelago far to the south. On the islands of Malta, a culture flourished in isolation, creating some of the world's oldest free-standing stone structures, temples so ancient they predate Stonehenge by over 1,000 years. These are not circles or rows, but complex buildings with lobed plans, intricate altars, and corbelled roofs, all constructed from massive limestone blocks. Among them, the Mnajdra temple complex stands as a masterwork of Neolithic engineering and celestial observation. Perched on a cliff overlooking the Mediterranean, its lower temple is a marvel of intentional design. Its main doorway is not just an entrance, it is a carefully calibrated instrument. On the mornings of the spring and autumn equinoxes, when day and night are of equal length, the rising sun performs a perfect alignment. A beam of light passes directly through the center of this doorway, traveling unimpeded to strike a specific, central stone slab deep within the inner chamber. This is not a broad wash of illumination, but a targeted spotlight marking a moment of cosmic balance. The builders did not stop with the equinoxes, however. The temple's architecture also captures the extremes of the solar year. At the summer and winter solstices, the sun's position on the horizon shifts. On those days, the rising sunbeams no longer pass through the doorway center. Instead, they slide to the sides, illuminating the distinct edges of the large megaliths that flank the entrance. One solstice lights the left edge, the other the right. This creates a complete solar calendar in stone, marking all 4 cardinal points of the sun's yearly journey with unambiguous clarity. The implications are profound. Here, thousands of years before formalized calendars, a society without metal tools engineered a permanent, immovable observatory that could predict and celebrate the sun's changing relationship with the Earth. It demonstrates a systematic, scientific understanding of cyclical time, an understanding so vital it was literally built into the walls of their most sacred spaces. Across the ocean, on a barren ridge overlooking the desert coast of Peru, a different kind of calendar stands in stark silhouette. This is Chankillo, a complex of 13 stone towers built over 2,300 years ago, long before the rise of the Inca Empire. From a distance, the towers appear as a row of jagged teeth on the horizon, spaced at irregular intervals along the crest of a hill. Their purpose remained an enigma for centuries, seen as a fort or a ceremonial center. But the truth, once deciphered, reveals a concept of breathtaking simplicity and clarity, an observatory so direct it feels like a revelation. The genius of Chankillo lies not in a single, dark passage or a grand circle, but in two simple observing points located to the east and west of the ridge. From the western observation point, an individual would watch the sunrise each morning. As the sun journeyed north and south through the year, its point of emergence on the horizon would shift. And here is the perfect function of those 13 towers. They act as giant stone calibration marks. On the December solstice, the southernmost summer sun in the southern hemisphere would rise directly to the left of the southernmost tower. In the following days and weeks, the sunrise would march steadily northward, appearing between the gaps in the towers until it reached the June solstice, where it would rise to the right of the northernmost tower. Then the process would reverse. From the eastern observation point, the same precise sequence would track the sun's setting positions. This means that without any moving parts, without any need for calculation on a given day, anyone standing at the correct observation post could determine the date within a couple of days simply by noting which tower framed the sun. It is a solar calendar made permanently visible, a public timekeeping device built into the landscape itself. The profound implication of Chankillo is its independence. This sophisticated understanding of the solar year emerged in complete isolation from the megalith builders of Europe or the temple architects of Malta. It stands as powerful, undeniable proof that the drive to measure the heavens, to anchor human life to cosmic cycles, was not a cultural artifact passed from one civilization to another. It was a fundamental spark of the human mind, a logical and beautiful response to the sky above, igniting again and again wherever people looked up and wondered. But the story does not end with stone. A discovery in a German forest revealed that this celestial knowledge had evolved into something new, something you could hold in your hands. Found near the town of Nebra, a bronze disc about the size of a dinner plate lay buried for over 3,600 years. This is the Nebra Sky Disc, and it is considered the oldest known concrete depiction of the cosmos in the world. Its surface is a dark blue-green patina, inlaid with gold symbols that are not random decorations. They are a deliberate code. A cluster of 7 stars represents the Pleiades, a star group important to ancient cultures for marking agricultural cycles. A large golden circle and a crescent shape clearly depict the sun and the moon. Most telling are 2 golden arcs along the disk's edges, each spanning exactly 82 degrees. Researchers believe these represent the angle between the sun's rising and setting points at the solstices, as seen from that specific location in central Germany. This was not a monument aligned to the sky, it was a portable model of the sky itself. The disk represents a quantum leap in thinking. It shows that astronomical knowledge had moved beyond aligning massive stones with horizon events. Now, the complex relationships between celestial bodies, their positions, and their meanings had been abstracted, systematized, and encoded into a durable, transferable object. It was likely used as a sophisticated calendar, combining lunar and solar observations to predict the correct time for planting or for holding ceremonies. The Nebra Sky Disc is proof that this early science was becoming formalized knowledge, something that could be taught, carried, and used by a society no longer bound to a single sacred site to read the heavens. This progression from landscape to portable disc presents us with an even deeper mystery. How did any of this begin? How do you start from nothing, with no written language, no metal tools, and no concept of the wheel, and end up with a structure that can predict a solstice sunrise to within a fraction of a degree? The sheer practical puzzle of it forces us to reconsider the meaning of technology. we must imagine the first steps, the foundational acts of observation that turned wonder into working knowledge. It likely began not with grand ambition, but with simple, repeated attention. A curious individual, or perhaps a lineage of sky watchers, would have noticed a pattern over the years. They would mark where the sun rose on a prominent tree or a distant hill. They would watch season after season as that point of sunrise moved along the horizon, traveled north, then south, then back again. The critical discovery was identifying the standstill points, the solstices, where the sun appeared to pause for a few days before reversing its journey. These became the fixed anchors in the celestial cycle, but knowing a point on the horizon is one thing. Translating that knowledge into a permanent, colossal stone alignment miles away is an engineering feat of a different order. Without written plans, how did they communicate the design across a generation of builders? Without precision instruments, how did they ensure a sightline remained true over a distance of hundreds of meters? The theories proposed by archaeologists and experimental builders give us a glimpse into a profoundly different kind of ingenuity. The process likely started with a series of wooden stakes and long ropes. Using a simple but effective method, they could have established a true east-west line by marking the shadow of a vertical pole at sunrise and sunset, then bisecting the angle. To project a long, straight line across uneven ground for an avenue or an alignment, they could have used a series of sighting poles, lining them up visually to create a perfectly straight guide. The most challenging task, establishing an alignment to a specific solar event like the solstice sunrise, would have required immense patience. A master observer would have stationed themselves at the intended center point of the future monument. On the morning of the solstice, they would have placed a marker, perhaps another stake, directly in line with the rising sun over a chosen landmark on the distant horizon. That exact line of sight from the center to the horizon marker then became the sacred axis, the non-negotiable blueprint for everything that followed. All the hauling of stones, all the digging of holes, would have been done to physically manifest that invisible line upon the earth. This was engineering through embodied knowledge, where the blueprint existed not on parchment, but in the collective memory and practiced skill of the community, passed down through story, ceremony, and direct apprenticeship. The tools were simple, but the application of sustained observation and communal effort was a technology in itself, one that could move mountains of stone to mirror the motion of the heavens. The sun's reliable journey provided a powerful annual heartbeat for these ancient societies, yet the night sky held its own, more subtle rhythms that some researchers believe these builders also learned to hear. While a solstice alignment is a spectacular, once-a-year event, the moon and stars present a far more complex puzzle. The evidence for their tracking is more subtle and often more hotly debated, pushing the boundaries of what we believe possible for prehistoric science. Take the moon. Its cycle is not the simple, monthly pattern it first appears to be. Over a period of 18.6 years, the points on the horizon where the moon rises and sets slowly migrate north and south, reaching extreme limits before swinging back. This is the lunar standstill cycle. At the major standstill, the moon rises at its farthest possible point north, a position it seems to hold or stand still for about a year. To an observer without precise records, this slow, 18-year dance would be incredibly difficult to discern from the faster monthly changes. Yet some researchers argue that monuments like Stonehenge were designed to encode this very cycle. They point to the 4 station stones that once stood outside the main circle, and to the pattern of the 56 Aubrey holes. The geometry created by these features, they suggest, could have been used to predict the moon's extreme positions, turning the monument into a long-term calculator far more sophisticated than a simple solar calendar. The debate is vigorous because proving intentional lunar alignment is statistically much harder than proving a solar one. A circle of stones has many potential sightlines, and over millennia, some will randomly point to lunar extremes. The question is whether the pattern is stronger than chance, a question that lies at the very heart of archaeoastronomy's scientific rigor. The stars introduce an even greater challenge. Claims occasionally surface that a monument aligns with a bright star like Sirius or a constellation like Orion's belt. The visual effect, however, is nothing like the dramatic solar spotlight of Newgrange. A star is a pinpoint of light, and its rising point shifts minutely each night due to the Earth's axial precession, a slow wobble that completes a cycle every 26,000 years. This means the starry sky that gleamed above the builders of Stonehenge 5,000 years ago was noticeably different from our own. Proving a specific stellar alignment requires not only precise astronomical back calculation, but also compelling cultural evidence that a particular star held profound meaning for that specific society. Without written records, that evidence is often circumstantial. So while the idea is captivating that our ancestors might have anchored their stones to the eternal fixed lights, the evidence remains in the realm of intriguing possibility rather than settled fact. This very uncertainty, however, highlights the sophistication of the inquiry. It shows us a field mature enough to celebrate clear solar alignments while rigorously questioning the more elusive patterns in the night, reminding us that true understanding often lies in knowing the limits of our knowledge as much as in the discoveries themselves. This undeniable wonder, however, arrives with a necessary question. Could it all be a magnificent coincidence, with thousands of ancient stones scattered across the landscape and dozens of potential celestial targets in the sky? The odds are that some will align by random chance. This is the core argument of the skeptics, and it is a vital dose of scientific caution that any serious investigation must confront. The human mind is a powerful pattern-seeking machine. We are wired to find connections, to see faces in clouds and constellations in random stars. This tendency, known as confirmation bias, can easily lead us astray. If we approach a site like Stonehenge already believing it to be an observatory, we might instinctively seek out and celebrate the alignments that fit our theory, while unconsciously ignoring the many sightlines that point to nothing of celestial significance. The challenge, then, is to move from compelling stories to statistically sound proof. How do we distinguish a purposeful astronomical design from an accidental lineup of stones? The answer lies in the mathematics of probability and the search for repeated patterns. A single alignment between one stone and one sunrise is weak evidence. But if we find the same specific alignment, say, to the winter solstice sunset replicated at multiple, geographically separate sites built by the same culture, the probability of that being an accident plummets. This is where the interdisciplinary rigor of archaeoastronomy proves its worth. Researchers use precise survey data and complex software to model the ancient sky, calculating the exact positions of celestial bodies thousands of years ago. They then run statistical tests to see if the number of alignments at a site exceeds what one would expect from random chance. It is a meticulous process of subtraction, aiming to strip away the noise of coincidence to reveal any true signal of intention. This scientific skepticism is not a dismissal of the builder's intellect, but rather the deepest form of respect. It insists that their achievements be measured by the most rigorous standards, ensuring that when we finally point to an alignment and call it intentional, we are not just seeing what we wish to see, but are bearing witness to a genuine fragment of prehistoric thought etched permanently into the earth. Yet this focus on precise measurement risks imposing a modern lens on an ancient mind. To label these places merely as observatories or calendars is to strip them of their soul. For the people who built them, the line between science and spirituality, between measurement and meaning, simply did not exist. The sky was not a distant clock to be read, but a living, sacred narrative. The sun was not a ball of plasma, but a deity, an ancestor, or a life-giving force. The moon was a powerful, cyclical goddess. the precise moment the solstice sun entered the chamber at Newgrange was not just a date on a farmer's almanac. It was a rebirth, a victory of light over darkness, a time when the veil between the world of the living and the realm of the ancestors grew thin. This profound connection transformed the monument's function. Yes, it marked a crucial agricultural turning point, signaling the gradual return of longer days. But more importantly, it created a controlled, awe-inspiring spectacle that reinforced the entire community's worldview. The ability to predict and stage this event was not just practical knowledge, it was sacred power. It likely resided with a specialized group, perhaps elders or ritual leaders, whose authority was derived from their unique relationship with the cosmos. When they announced the time for a ceremony based on the stars, or when they led the community to witness the sun's perfect alignment, they were not just sharing data. They were demonstrating a privileged connection to the divine order, legitimizing their role and unifying the people under a shared cosmic story. The monuments themselves became the permanent anchors of this story. The labor required to build them bound the community together in a common, generational purpose. The finished structure then stood as an immutable testament to that shared belief, a physical covenant between the people, their ancestors, and the heavens. To walk the avenue at Stonehenge during a solstice was to participate in that covenant, to have your place in the universe reaffirmed by the architecture of the world itself. So while we can admire the astronomical precision, we miss the full picture if we don't also see the temple, the theater, and the societal cornerstone. These sites were the beating hearts of their cultures, where calendar, cathedral, and community hall were one and the same. This leaves us facing one of the most profound puzzles of all. The solstice sunrise at Newgrange is not an annual event, but a generational one, requiring decades of observation to pinpoint with the accuracy its builders achieved. The lunar standstill cycle spans nearly 19 years, longer than a single individual's active period as an astronomer. How could such long-term, precise knowledge survive and remain uncorrupted across dozens of human lifetimes without a single written manual to consult? The transmission of this science was itself a monumental achievement, a cultural technology built not from stone but from memory and tradition. The primary vessel was the human voice through a rich and rigorous oral tradition. Critical information was not casually discussed. It was woven into the fabric of sacred stories, encoded in myths about gods and heroes whose journeys mirrored the paths of the sun and moon. These narratives, passed from master to apprentice in formal settings, were likely accompanied by rhythmic chants, songs, or poetic verses, all designed to make the complex data easier to memorize and recall verbatim. An apprentice would not simply learn a list of star positions. They would learn the story of the sky hunter whose belt pointed to the solstice hill, a story where every detail held celestial meaning. This knowledge was not for everyone. It was specialized, likely held by a select group of elders or sky priests, whose societal role was to be the living libraries of cosmic lore. Their apprenticeship was a lifelong commitment, a gradual absorption of patterns through repeated ritual observation. They would stand at the same stone year after year, watching the same horizon, verbally recounting what they saw and linking it to the stories of their predecessors. The monument itself acted as the ultimate failsafe, a permanent mnemonic device built into the landscape. You did not need to remember the exact angle of the winter solstice sunset. You simply needed to remember to stand at the center of the circle and look toward the great trilithon. The architecture held the knowledge in a fixed physical form, correcting any drift in the oral tradition. If a story began to change over generations, the stones themselves provided the immutable reference point, a silent teacher that would always show the truth on the appointed day. In this way, the community did not just build an observatory, they built an eternal classroom, ensuring that the precise science of their ancestors would outlast any single human memory. speaking across the centuries in the silent language of aligned stone and captured light. The global scale of this phenomenon forces us to confront a fundamental mystery. From the stone rows of Carnac to the solar towers of Chankillo, we see cultures separated by vast oceans and thousands of years arriving at a similar destination. They all built colossal stone monuments aligned to the sun. This striking parallel presents us with two possible explanations, each with profound implications for the story of human ingenuity. The first is the theory of cultural diffusion, the idea that this sophisticated knowledge had a single point of origin. Perhaps a seafaring civilization, now lost to history, traveled the ancient world, sharing the principles of astronomy and megalithic engineering with disparate peoples. This would explain the technical similarities and suggest a forgotten teacher in our collective past. The second explanation is independent invention. This argues that observing the sky is a universal human experience, and building monuments to mark its cycles is a logical, even inevitable, step for any settled society reaching a certain level of communal organization. In this view, the sun's path is a puzzle presented to every culture, and building a calendar in stone is simply a brilliant, repeated solution. So which is it? Did the knowledge spread from a common source, or did it spark to life independently, again and again? The evidence for diffusion is compelling on the surface. The core concept using massive, aligned stones to track solstices appears across continents. Proponents point to potential, though highly debated, similarities in artistic motifs or construction techniques as faint echoes of a shared tradition. They ask, is it more likely that this complex idea was invented once and carried, or that it was spontaneously reinvented multiple times? The argument for independent invention, however, is supported by the sheer isolation of many of these cultures. The builders of Chankillo in Peru had no conceivable contact with the Neolithic farmers of Orkney. Their worlds were completely separate, yet both identified the same solar problem, the need to track the year, and both arrived at a monumental architectural solution. This suggests the drive to understand and codify celestial cycles is a fundamental trait of the human mind when confronted with the need to organize agriculture, ritual, and time. The astronomical principles themselves are not hidden secrets. Any persistent observer can mark the sun's northernmost and southernmost points on the horizon over a lifetime. The true innovation was the societal will and resource to translate that observation into permanent landscape architecture. That will seems to have emerged wherever humans transition from nomadic life to settled farming, creating a need for precise calendar keeping and the communal labor force to achieve it. Therefore, these global parallels may not point to a single lost civilization, but to something even more remarkable: the inherent and universal capacity of the human species for scientific discovery. The same sky inspired the same awe, posed the same practical questions, and ultimately ignited the same brilliant spark of engineering, not once but many times over. This turns the narrative from a search for a forgotten teacher into a celebration of our shared human genius, an innate ability to read the world and write our understanding in the most enduring language we knew, stone. Yet just when we think we have traced this story to its earliest roots, a discovery in southeastern Turkey shatters the entire timeline. On a barren hilltop known as Göbekli Tepe, archaeologists uncovered something that should not exist. This is not a monument from the age of Stonehenge. It is from a time 6,000 years earlier, a staggering 11,600 years ago. This places its construction firmly in the pre-pottery Neolithic, a period we once imagined as a simple, nomadic chapter of human history. Here, communities of hunter-gatherers, people we assumed were solely focused on day-to-day survival, came together to execute a project of breathtaking scale and sophistication. They carved and erected enormous limestone T-shaped pillars, some weighing over 15 tons, arranging them into a series of at least 20 circular enclosures. The pillars are not crude blocks, they are works of art adorned with intricate, low-relief carvings of animals, foxes, snakes, boars, and birds, a stunning bestiary frozen in stone. The sheer effort defies old assumptions. This was not the work of a settled, farming society with surplus labor. It was achieved by people living off the wild land, suggesting a social organization and a shared purpose far more complex than we ever credited them with. Göbekli Tepe stands as a profound anomaly, a colossal question mark carved into the dawn of civilization. But its mystery deepens when we look beyond the stone menagerie to the sky above. The arrangement of these circles and the orientation of the massive central pillars within them has led some researchers to propose a celestial dimension that, if correct, rewrites history. Studies of the site's layout suggest the enclosures were not randomly placed. Specific structures appear to be aligned with the rising points of stars, most notably Sirius, the brightest star in our night sky. Other alignments may point to the solstices or to the star cluster of the Pleiades. This is a controversial hypothesis, as stellar alignments are notoriously difficult to prove for such ancient periods. The Earth's wobble means the night sky 11 millennia ago was markedly different, and pinpointing a star's exact rising position requires immense precision. Yet the potential implications are revolutionary. If the builders of Göbekli Tepe were intentionally tracking stars, it means sophisticated astronomical observation was not a product of agriculture and settled life, as we have long believed. It was a cause. The very need to gather at precise times for rituals linked to the stars may have been the catalyst that brought nomadic bands together regularly, fostering the cooperation and social structures that eventually made farming and permanent settlement possible. In this radical view, the temple came before the city, the calendar carved in stone, and sky preceded the wheat field. Göbekli Tepe does not just push back the timeline of megalithic science, it inverts the entire narrative of human progress, suggesting that our first great leap forward was not taken for bread, but for meaning, driven by a desire to connect with the cosmos and mark our place within its eternal cycles. The silent principles locked within those ancient stones would find a voice over 2,000 years later in the wreckage of a Roman shipwreck. In the clear waters off the Greek island of Antikythera, divers in the early 1900s recovered a corroded lump of bronze and wood, its original form utterly unrecognizable. For decades, it sat in a museum drawer, a curious but baffling artifact. Then, painstaking modern analysis using X-ray and advanced imaging revealed its truth. This was no simple statue fragment. It was the Antikythera Mechanism, a hand-powered, geared device of staggering complexity, built in the 2nd or 1st century before the Common Era. It is, in essence, the world's oldest known analog computer. Its purpose was not to compute sums, but to model the cosmos. By turning a hand crank on its side, an operator could advance a series of interconnected bronze gears. These, in turn, would move delicate pointers across several dials on the device's face, predicting the positions of the sun and moon, the phases of the lunar cycle, and even the dates of upcoming eclipses. One dial tracked the 4-year cycle of the Panhellenic Games, tying celestial time to human ritual. It was a portable cosmos in a wooden box, a masterpiece of Hellenistic engineering that could simulate the very motions ancient people had once marked with unmovable stones. This extraordinary artifact forms a conceptual bridge across millennia. It demonstrates what becomes possible when the foundational seed of celestial observation, so carefully nurtured by the megalith builders, is given time, writing, and metalworking technology to flourish. The Neolithic sky watcher at Stonehenge used stationary stones to mark where the sun would rise on a specific day. The Greek engineer who crafted the Antikythera Mechanism internalized that entire celestial dance into a system of precisely calculated gear ratios. One method is monumental and fixed, the other is miniature and dynamic, but the core intellectual pursuit is identical: to understand, predict, and represent the orderly patterns of the heavens. The mechanism is a powerful echo, proving that the scientific curiosity first expressed in aligned megaliths was not a dead end, but a continuum. It evolved from marking an event on the horizon to building a mechanical model that could run that event forward or backward in time at will. This continuum suggests that the impulse to decode the universe is a constant thread in the human story, manifesting in whatever technology a culture commands, from levers and ropes to gears and dials. This entire celestial architecture relied on a simple, elegant tool provided free of charge by nature itself. The horizon was the first and most critical instrument in the ancient astronomer's toolkit. For a culture without telescopes or written charts, the distant line where Earth meets sky became a giant, calibrated ruler against which the entire cosmos could be measured. The process was beautifully straightforward, requiring nothing more than patient observation. A sky watcher would choose a fixed observation point, perhaps a specific stone or a cleared platform. From that exact spot, they would watch the sun rise each morning, noting precisely where its first sliver of light broke over the landscape. That point of emergence was not static. As the seasons turned, the sunrise location would migrate slowly along the horizon, traveling northward in the spring and summer, then reversing its journey southward in the fall and winter. The key was to identify and mark the extremes. The northernmost point marked the summer solstice, the longest day. The southernmost point marked the winter solstice, the shortest day. By using a distinctive feature on the horizon, a sharp notch between two hills, the peak of a distant mountain, or a solitary tree, they could track this migration with remarkable accuracy. They weren't measuring angles with a protractor, they were using the landscape itself as a permanent, visual record. This is why the specific location chosen for a monument was never accidental. Building on a high ridge or a carefully selected plain with a clear, undulating horizon was a deliberate design decision. It provided the necessary backdrop against which the celestial drama could be read. The monument then served to formalize that reading, to take the invisible line of sight from the observer's eye to that distant notch and make it permanent in stone. The Great Stone Circle or Passage Tomb became the fixed observation point, ensuring that every generation could stand in the exact same spot and witness the same cosmic alignment, their connection to the cycle of the year made tangible by the silent conversation between built stone and natural skyline. This celestial knowledge was far more than a sacred abstraction. It was the essential operating system for an entire society, a practical tool that transformed survival from a gamble into a managed endeavor. The ability to pinpoint the solstices and equinoxes gave these communities the ultimate reference points, the fixed pillars of the year. From these four celestial anchors, they could construct a reliable calendar, dividing the solar year into meaningful segments. This was not about marking dates on a wall, but about synchronizing every critical aspect of communal life with the immutable rhythm of the cosmos. The most visible application was, of course, ritual. The winter solstice ceremony at Newgrange, the gathering at Stonehenge for the summer sunrise, these were profound spiritual events, but their timing was not arbitrary. They were scheduled with precision because the celestial moment itself was the main participant, the divine actor making its entrance on a stage built of stone. By predicting this moment, the ritual leaders could prepare the community, gather them from scattered settlements, and orchestrate a shared experience that reinforced their beliefs and social bonds at the most potent time possible. The calendar dictated the ceremonial heartbeat of the culture, yet beneath this layer of sacred theater lay a foundation of stark, practical necessity. The difference between a bountiful harvest and a season of hardship could hinge on a matter of weeks. Knowing precisely when the last frost had passed and the soil was warm enough for seeds was knowledge as valuable as gold. The spring equinox, with its balance of light and dark, served as a powerful signal. When the sun rose due east and set due west, it told the observers that the deep cold was retreating. It was time to prepare the fields. Conversely, the autumn equinox signaled the approaching end of the growing season, a warning to gather crops before the first frosts. For herding communities, these celestial markers dictated the seasonal migration of animals to higher summer pastures and back to sheltered winter valleys. A calendar based on solar observation removed the guesswork. It replaced reactive scrambling with proactive planning. A community that knew with certainty that the sun would soon reach its southern standstill could begin storing food, repairing shelters, and organizing winter hunting parties well in advance. This predictability brought stability. It allowed for population growth, for the accumulation of surplus resources, and for the complex social organization needed to undertake projects like building megaliths in the first place. The stones that tracked the sun were, therefore, the guarantors of the society's continuity. They linked the awe-inspiring vastness of the sky directly to the planting of a single seed and the security of the next generation. In this seamless integration, we see the true genius of this early science. It served the spirit and the stomach in one unified, elegant system. But the experience these monuments offered was not limited to the eyes alone. A new field of research is revealing that the builders may have engaged another powerful sense, designing their sacred spaces to be heard as well as seen. This is the study of archaeoacoustics, and it suggests that sound, resonance, and echo were not accidental byproducts of stone construction, but intentional features of a multisensory ritual experience. At Stonehenge, for instance, researchers have noted the unusual acoustic properties created by its standing stones. The hard, smooth surfaces of the sarsen stones reflect sound in specific ways, and the circular arrangement can create a reverberant, almost enclosed acoustic environment, even though the structure is open to the sky. Some experiments suggest that rhythmic drumming or chanting within the circle would have produced a powerful, immersive sound, one that could feel as if it were emanating from the stones themselves, blurring the line between the human participants and the monument. This integration of sound and architecture reaches a breathtaking zenith at a far older site, the Hal Saflieni Hypogeum on Malta. This is not a structure built above ground, but an elaborate, three-level subterranean temple complex carved from solid limestone around 6,000 years ago. Its chambers and passages are a labyrinth of carved stone, and its acoustics are nothing short of extraordinary. In one particular chamber, known as the Oracle Room, sound behaves in a remarkable way. A deep male voice, spoken or chanted into a small niche in the wall, can produce a resonance that vibrates through the entire room, felt in the bones as much as heard by the ears. This low-frequency resonance would have been profoundly physical and disorienting, potentially altering states of consciousness during rituals. The effect is so precise it seems undeniably deliberate, a feature engineered by the carvers of the stone. When we combine this auditory dimension with the celestial alignments, a richer picture of ritual practice emerges. Imagine a ceremony at a site like Newgrange. The community gathers in the pre-dawn darkness of the winter solstice. As they wait, chanting or rhythmic percussion begins, the sound waves bouncing and amplifying within the stone passage, building anticipation. Then, at the precise predicted moment, the first beam of sunlight pierces the roof box. That silent, visual miracle now occurs within a cocoon of powerful, resonant sound. The light and the acoustics would have worked together to create an overwhelming, multisensory spectacle, one that could induce awe, trance, or a profound sense of connection to the divine. This suggests the builder's sophistication extended beyond astronomy. and engineering into an intuitive understanding of psychoacoustics, how sound affects the human mind and body. They were not just tracking celestial bodies, they were choreographing complete experiential environments, where the architecture served as an instrument to harmonize the human, the earthly, and the cosmic into a single, unforgettable moment of meaning. The sky that served as their textbook and their temple no longer exists for most of us. For the builders of these monuments, the night was a realm of profound clarity, a deep velvet black pierced by thousands of shimmering points of light. The Milky Way would have arched overhead not as a faint, ghostly smear, but as a brilliant river of stars so vivid it cast faint shadows on the ground. Constellations were not just patterns, they were dense clusters of stars within a sea of even more stars, a crowded, dynamic tapestry that turned slowly through the seasons. This was the essential canvas for their observations, a perfectly dark backdrop against which the subtle movements of planets and the moon's phases stood out with stark precision. It was a sky that demanded attention, that inspired stories, and that made the connection between earthly life and cosmic order feel immediate and undeniable. Our modern experience is a pale imitation, separated by a veil we have woven ourselves. The culprit is light pollution, the artificial glow from our cities, towns, and roads that scatters into the atmosphere, washing out the stars. For over 80% of people in North America and Europe, the Milky Way is now completely invisible from their homes, where an ancient observer might have seen several thousand stars on any given night. A suburban sky now reveals only a few dozen of the very brightest. This is more than an aesthetic loss, it is a profound disconnect from our own history. We look at the alignments of Stonehenge or the symbols on the Nebra Sky Disc, and we analyze them intellectually, but we struggle to feel the visceral awe that was their source. The perceptual gap is vast. Imagine trying to understand the genius of a master painter while viewing his work through a thick, fogged pane of glass. You can see the shapes and the composition, but you miss the texture, the depth, the subtle play of light and shadow that gives the piece its emotional power. Our light-polluted skies are that fogged glass. They obscure the very phenomenon that sparked millennia of scientific and spiritual inquiry. We have, in a very real sense, lost the shared visual language that once connected every human culture to the cosmos. This makes the achievements of the megalith builders even more remarkable to contemplate, for they sprang from a relationship with the night sky that we can now only reconstruct with effort, traveling to remote deserts or mountains to catch a fleeting glimpse of what was, for them, simply the world as it was. This evidence compels a fundamental shift in how we view our distant ancestors. The term primitive, often used to describe these Stone Age societies, begins to crumble under the weight of their achievements. It is a label that carries connotations of simplicity, of a mind concerned only with immediate survival. But what we find in these aligned stones is the very opposite. We find the capacity for profound abstract thought, to observe the sun's wandering path and conceive of it as a cyclical journey that can be measured and marked is an act of high abstraction. It requires stepping back from the sensory experience of each individual sunrise to perceive a grand, invisible pattern unfolding over years. This is not a concrete, survival-based skill like making a spear. It is the birth of a scientific model, a theoretical framework for understanding time itself. The scale of these projects reveals another critical faculty, generational foresight. A single individual could never hope to complete Stonehenge or raise the stones of Carnac. The builders were not working for themselves or even for their children. They were investing in a vision that would only be fully realized by their grandchildren's grandchildren. This represents a staggering leap in social and temporal imagination. It requires a shared cultural narrative so powerful that it can compel people to haul 50-ton stones for a purpose whose final form they will never see. This is not the behavior of a simple, present-focused group. It is the hallmark of a sophisticated culture with a strong sense of legacy, identity, and a place within a continuum of time that stretches far beyond a single lifespan. The engineering itself speaks to a sophisticated, if non-written, form of mathematics and geometry, establishing a straight line over a kilometer, as at Carnac, or ensuring a passage is angled precisely to admit a single beam of light, as at Newgrange, requires practical geometry. The builders understood concepts of alignment, perpendicularity, and proportion. They used ropes, stakes, and sightlines to translate celestial angles into terrestrial measurements. This is applied mathematics. Their technology was not metal and microchips, it was leverage, sledges, and an intimate knowledge of materials. But the intellectual process, the problem-solving, the iterative testing, the precise execution, is identical to that of any modern engineer. They simply worked in a different material language, one of timber, fiber, and stone. Most importantly, their method was rigorously empirical. Their science was built on repeatable observation. They did not guess where the sun would rise at the solstice. They watched year after year, noting its position against the horizon until the pattern became undeniable. They then tested their understanding by building a structure to see if the predicted alignment held true. This cycle of observation, hypothesis, and verification is the bedrock of the scientific method. They were not mystics blindly worshipping the sky. They were investigators decoding its laws, using the landscape and their monuments as both laboratory and record. So what then do we call this? It is not primitive science. It is profound science expressed through a Neolithic medium. These communities possess the core cognitive toolkit we associate with advanced thought: abstraction, long-term planning, collaborative project management, geometric reasoning, and empirical validation. The difference between them and us is not one of intelligence or capability, but of accumulated technology and notation. We have computers and textbooks, they had memory and myth. We write equations on paper, they wrote alignments in the earth. To dismiss them as primitive is to mistake the tools for the mind that wields them. These silent stone sentinels do not mark the endpoint of a simple culture. They stand as the enduring signature of a scientific revolution that happened not in a laboratory, but in the collective mind of humanity, thousands of years before history even thought to write its name. This profound intellectual legacy, however, has sometimes been overshadowed by more sensational claims. The undeniable wonder of these sites has a gravitational pull that attracts ideas far beyond the evidence, from tales of ancient astronauts to myths of a single, lost super-civilization seeding knowledge across the globe. It is crucial to navigate this landscape with care, to distinguish between the disciplined detective work of archaeoastronomy and the compelling stories of the fringe. The rigorous approach we have explored relies on statistical probability, archaeological context, and reproducible celestial mechanics. It builds a case slowly, stone by stone and alignment by alignment, accepting that some mysteries may remain unsolved. The fringe often operates in reverse, starting with an extraordinary conclusion like visitation from other worlds, and then interpreting ambiguous evidence to fit that pre-existing narrative. While these stories can be entertaining, they inadvertently rob our ancestors of their greatest accomplishment, their own innate genius. The genuine mystery is compelling enough. We do not need to invent extraterrestrial teachers or vanished Atlanteans to explain the alignments at Newgrange or the precision of Chankillo. The truth, as we are discovering, is more historically significant and far more respectful. It tells us that the human capacity for observation, engineering, and abstract thought is not a modern invention, but a deep and ancient part of who we are. Crediting these staggering achievements to the cultures that actually built them, to the generations of sky watchers and stone movers, restores their proper place in our shared human story. It transforms these monuments from potential artifacts of a forgotten other into enduring testaments to the universal spark of curiosity that exists right here on our own planet, within our own species. The silent stones have kept their secrets for millennia, but we are finally learning to listen with new ears. The quiet revolution in understanding these ancient monuments is being driven by a suite of technologies that act like a second sight, revealing what has been hidden and testing what was only guessed. At the forefront is a tool called LiDAR, which stands for light detection and ranging. Imagine flying a plane or drone over a dense, jungle-covered landscape. Instead of taking a photograph, the equipment fires millions of rapid laser pulses at the ground. These pulses penetrate the thick canopy of leaves and bounce back from the solid earth below. By measuring the time it takes for each pulse to return, a computer can build an astonishingly precise, three-dimensional map of the ground surface, stripping away every single tree and bush to reveal the naked topography. What emerges from this digital unveiling are shapes, the long, straight lines of ancient roads and processional ways, the perfect rectangles and circles of plazas and ceremonial centers, the unmistakable mounds of pyramids and platforms, all lying invisible beneath a living green carpet. In places like the jungles of Central America, LiDAR has uncovered entire lost cities, rewriting our maps of ancient civilizations. For the study of megalithic landscapes, its power is equally transformative. In Britain, LiDAR surveys have revealed new cursus monuments, long ceremonial earthworks, and subtle patterns in the land around known stone circles, showing that what we see today is often just the heart of a much larger, carefully orchestrated ritual complex. It allows researchers to see the forest for the trees, quite literally, and understand how these monuments were integrated into a grand, designed environment. This technology does not just find new stones, it finds the connections between them, revealing the full scale of our ancestors' ambition to reshape their world. But seeing the shape of the land is only half the story. The other half lies in accurately recreating the ancient sky. This is where sophisticated simulation software enters the picture. For decades, testing an astronomical alignment was a painstaking manual process, involving complex calculations and a fair bit of educated guesswork. Today, researchers can build incredibly accurate three-dimensional digital models of a site, from the tilt of a single stone to the profile of the distant horizon. They then feed this model into astronomical simulation programs that can calculate the precise positions of the sun, moon, and stars for any date in the past, accounting for subtle changes in the Earth's orbit and axial tilt over thousands of years. The result is a virtual time machine. An archaeoastronomer can now stand at a digital version of the center of a stone circle and watch a simulated sunrise on the winter solstice in the year 3000 before the Common Era. They can see exactly where the first light breaks the horizon and trace that beam of light across the landscape to see if it truly strikes a targeted stone or illuminates a dark passage. This allows for the rigorous testing of alignment hypotheses with a level of precision that was once impossible. Is that notch in the hills really where the summer solstice sun set? The simulation can show it to within a fraction of a degree. Could this group of stones have been used to track the lunar standstill cycle? By running the simulation across the entire 18.6-year period, researchers can look for repeated patterns and statistically significant correlations. This technological partnership between ground scanning and sky simulation is turning speculation into science. It is allowing us to move from asking, "Could this be an alignment?" to demonstrating with high probability that it is. Each confirmed alignment is another recovered piece of a vast prehistoric puzzle, helping us read the intentions behind the stones with a clarity our predecessors in this field could only dream of. Despite our growing technical understanding, the inner world of the builders remains partially veiled, a landscape of profound, unanswered questions. We can map the stones and calculate the alignments, but the stars they chose to watch whisper secrets we cannot fully hear. We know some monuments track the sun and moon with precision, but which specific stars or constellations held the deepest meaning? The Pleiades cluster appears on the Nebra Sky Disc and is implicated at sites like Göbekli Tepe, often linked to agricultural timing across many ancient cultures. But was it a practical marker for planting, or did it represent a group of ancestral spirits in the sky? Did the bright star Sirius, revered later by the Egyptians, hold similar significance for the megalith builders of Europe, its heliacal rising signaling a key moment in their year? Without written texts, the rich mythological stories that gave these points of light their power are lost to us. We see the targets of their observations, but the celestial stories they told around their fires remain silent. This extends to the very method of their science. We understand the possible tools, but the living system of knowledge transmission is a ghost in the archaeological record. How exactly was this sophisticated data encoded and taught from one generation to the next? We speak of oral tradition, but what did that actually look like? Were there formal schools of sky watchers where apprentices memorized complex chants detailing the lunar standstill cycle? Did they use intricate knot systems in chords or patterns carved on portable wooden tablets as memory aids that have long since decayed? The leap from observing a pattern to building a monument that encodes it for centuries implies a rigorous, reproducible teaching method, a curriculum of the cosmos that has left no physical trace. We see the magnificent result of their education system, but its textbooks have turned to dust, and for every stunning success like Stonehenge or Newgrange, there must have been experiments that did not endure. Were there failed or abandoned projects we haven't found? A grand alignment that missed its mark by a crucial degree, its stones left lying in a quarry or toppled in a field and later buried. A wooden prototype circle that rotted away, leaving only post holes that we might misinterpret. The archaeological record is inherently biased toward what survived. The journey to perfecting solstice alignments was likely paved with trials and errors, with community efforts that did not achieve the desired celestial effect and were perhaps ritually decommissioned or forgotten. These silent failures would teach us just as much as the successes, revealing a process of trial, observation, and correction, but they may be lost forever beneath the soil. Ultimately, the greatest mystery is the narrative that wove it all together. We can piece together the astronomical functions, but what was the full cosmological story? How did the journey of the sun, the phases of the moon, the fixed tapestry of stars, the spirits of the ancestors within the tombs, and the sacred hills and rivers of the living landscape all connect into one grand, unified whole? The monuments suggest they saw no separation. The winter solstice sun entering Newgrange wasn't just a solar event. It was the rebirth of an ancestor, a beam of light traveling from the horizon of the living to the chamber of the dead, all within a mound that mirrored the surrounding hills. The full story, the epic poem of stone and sky that gave every alignment its emotional and spiritual weight, is the true lost artifact. We have recovered the skeleton of their science, the precise astronomical and engineering principles. But the flesh and blood of their belief, the myths that made the stones sing and the stars speak, that inner world of meaning resonates now only as a haunting echo in the silent spaces between the megaliths. The evidence is now too vast and too precise to dismiss. From the focused beam in Newgrange's chamber to the marching sun between Chankillo's towers, from the grand solstice axis of Stonehenge to the portable cosmos of the Nebra Sky Disc, a clear pattern emerges across continents and millennia. These were not accidental arrangements. They represent a deliberate, sophisticated, and globally recurring scientific practice. The conclusion is inescapable. the systematic observation and measurement of celestial cycles, the very foundation of science, began not with the philosophers of ancient Greece, but thousands of years earlier in the minds of people working with stone and sky. This rewrites our intellectual history, pushing the dawn of empirical discovery deep into our prehistoric past. It reveals a truth more remarkable than any fiction. The drive to comprehend the cosmos is a universal thread in the human story, a spark of curiosity that ignited independently wherever people looked up and sought meaning in the turning of the heavens. These silent stone sentinels are therefore far more than ancient ruins or ritual sites. They are humanity's first laboratories, our first observatories, and our first enduring attempts to write the laws of the universe into the very fabric of our world. They stand as timeless testaments to an ingenuity defined not by the tools available, but by the profound capacity of the human mind to see pattern, to plan across generations, and to seek harmony with the great cycles of nature. So the next time you see a photograph of a stone circle or walk past an ancient mound, try to see it with new eyes. Look beyond the weathered rock to the intention locked within it. Support efforts to preserve our dark night skies, that vital canvas our ancestors knew so intimately, and remember that the story of human discovery is far longer, far richer, and far more wondrous than we ever knew, written in a language of aligned stone and captured light, waiting for anyone who chooses to look.